So good to be here. My name is Kyle Rojas. I lead the business team in a nerdy crypto startup called Avail, which I'll talk more about later. Quick on my background, I was in the military. I worked on Wall Street at Goldman Sachs, took a huge pay cut to find some fulfillment, and now I've been working full-time in crypto for about 4 years. As you can imagine from the title, I'm going to talk about a modular infrastructure shift that's happening in Web3, as well as how and why I think it's an inevitable part of the future. Hopefully it doesn't get too nerdy, and if anything, we can try to connect the dots at the end with some questions. But let's take a trip down memory lane on how we got here, which will be a review for some in the crypto space, but I know there are a good amount of non-crypto folks here as well, so I think it's worth the time. To start, how do we get to Web3 in the first place? Again, probably a review for everybody. Web 1, let's say, starting in the late 80s, early 90s, where the internet was read-only, there were static websites, limited user interaction, and more of a focus on information dissemination. Web 2, starting around the social media era, was where we could read and write. It was interactive. There was user-generated content where we, as the users, could create content as opposed to just consume it. But in Web 2, to strike a frictional chord, companies own and control everything. Your profiles on socials, even down to the pictures we post, and even the domains that people acquire, like in your industry, like they aren't truly ours. They can be deleted, they can be altered, even if they're trusted entities, and whatever else might happen, especially if, let's say, a company wanted to take down competitors and everyone who was part of that company in a domain space or whatever got taken down with it, or even more relevant is what if a government wanted to shut things down? It'd be very easy going straight to a company that custodied everything. So finally, in Web 3, we can read, write, and we actually own and control what's on the internet. And also have it sit on immutable ledgers controlled by no single entity. The data is unchangeable. So no person, no company, no government can take or change something without our express permission. It's a true paradigm shift, and I think it's been an extremely important evolution for the internet. But like with Web 1 and Web 2, the perfect blockchain solution to power smooth Web 3 activities has taken time and many, many iterations, and still not even close to final form yet, to be honest. Just a little history. We started with Bitcoin, the Bitcoin network in 2009, which is a blockchain. The first and still one of the most important parts of this space, with benefits like extremely high decentralization, high economic security. And if you're curious as to what a blockchain is, I think some people mentioned it yesterday, but you can think of it, in my mind, I think of it as an operating system like Apple OS or Android, where people can develop applications, what we call decentralized applications or dApps, and where the history of all those transactions on those applications are recorded permanently in a digital ledger. But even as arguably the most decentralized and censorship-resistant blockchain, developers still can't really do a ton on Bitcoin. It has very low transactions per second, as you can see, and unlike other blockchains, Bitcoin lacks OP codes or opcodes that can read and write the current state of the blockchain, and these opcodes are essential for creating complex tasks that are triggered by blockchain transactions, which is why there are really no dApps being built on the network, at least not yet. People are working on it. And then came Ethereum in 2014 to 2015. Ethereum enabled transactions that contain executable code, enabling complex smart contract activity. And what followed was a massive Cambrian-style explosion of dApps, again, decentralized applications, and end users that were using those dApps. But with the level of adoption Ethereum saw, along with its low throughput, the transactions generated took up the block space over time, which is essentially throughput. And to get those transactions into each Ethereum block due to congestion, people that pay higher and higher fees. Any of us that have been in the space for a number of years have probably paid over $100 for a single transaction, buying and selling something simple, right? That's not what the future of the internet feels like. And if we see this now and there are only 500,000 people interacting on Ethereum, how can we expect the world to use something like Ethereum with many billions of people, especially when those that don't want to pay even a cent for a transaction or don't want to feel like they're paying anything at all? So people had to adapt. Then came the world of faster and cheaper layer 1 blockchains, starting around 2017 with projects such as Solana, BNB Chain, Near, and others. And to clarify, layer 1 means it's the top level blockchain where information like transactions settle as a source of truth. These layer 1s had faster execution times. They had a tiny fraction of the cost and have transactions per second hundreds of times higher than Ethereum. So these were huge benefits compared to Ethereum's layer 1 environment. But there are also huge drawbacks, just like anything. Centralization is a major factor. Multiple layer 1 blockchains, even one of the top 5 chains with tens of billions in total value locked, have literally stopped working. They stopped working for multiple periods of time, a testament to, in my mind, how important decentralization truly is. And the fact that a blockchain can be stopped is worrisome, let alone that one has stopped multiple times. There's also a large disparity of the amount of tooling on these other layer 1s because they use different languages. This might not mean as much, but Ethereum uses Solidity, Solana uses Rust, others use MoveVM, and so on. Move language. So compared to Ethereum, the tools that help build dApps that in the end bring in and keep end users aren't as robust on other layer 1s. So for now, at least, arguably, Ethereum remains the king of the smart contract platforms. There are legitimate arguments for chains like Solana, and I can see the merits of those arguments, but Ethereum is the most decentralized with the highest uptime. Ethereum has the most developer tooling. Ethereum arguably has the largest developer community around the Web3 space when you're counting all these different people building in the Ethereum world. And focusing on Ethereum for now, many thousands of developers, instead of moving away from Ethereum to go to these layer 1s or something like that, they started working to scale Ethereum instead. They started taking the execution of transactions off-chain, or to say it another way, onto another chain, and then post or settle those transactions onto Ethereum, all to increase the throughput and scalability of the layer 1. It started with the oldest layer 2s. They started to launch around 2018 when there was only a handful, and then just to describe what a layer 2 is, or in other words, a roll-up, it's when one of these chains take those transactions and they roll up to the layer 1. That's why they're called layer 2s, layer 1s, and so on. Then it expanded across dozens of layer 2s over the following years. A lot of different experimentation was taking place, and now there are over 140 roll-ups, blockchains building out, and that will all be settling on Ethereum, not only in the Ethereum environment, but also in things like Solana environment and so on. And many, many, many more, like hundreds of different chains are working to see their visions through, get funding, and tinkering with their infra stacks. This move to a roll-up-centric ecosystem was just the first step in what we're calling modularizing the entire blockchain stack. And now let's look at the ways people are doing that. To set the stage, there are 4 main functions of a blockchain. The first is execution. As I mentioned, this means the processing of our transactions and executing smart contracts. The second is settlement, which means finalizing those transactions and then facilitating cross-chain interactions. And then there's consensus, which is the process that establishes a shared agreement on the validity of the truth of those transactions, and which is absolutely crucial for maintaining the integrity and security of a chain. And finally, there's data availability, or DA. DA is the process of ensuring the public availability of the data posted on that chain. Without DA, new blockchains cannot be created, as previous blocks must always be provably correct by the public before creating the next block. And to think about it another way, a blockchain can be seen as a book, a digital ledger, and you can't write the next page until people have collectively verified the previous page was correct. So that's DA. And to take a more bird's eye view, let's look at what modularity or modularization of blockchain means. It's good to think of what modularity is not, right? And that's the opposite of being monolithic. Monolithic is when a vertically integrated blockchain does all those functions and more on its own, from execution to data availability. Modularity is the separation of those functions by way of specialization. It's where a technology by another ecosystem, another project, can be adopted to make the chain work as efficiently as possible. These can operate more efficiently since each project concentrates solely on that specific functionality and technology. It's where there are a bunch of different specialized Legos that people are mixing and matching to find the most performant and least expensive fit for each and every function with an infrastructure stack. And if you think about it, this is Web3 evolving as the internet did and how it still operates today. because the internet is made up of tens of thousands of microservices, tens of thousands of businesses, all operating behind the scenes. So Web3 is naturally finding the same evolution path as the internet. And there are all sorts of ways that people are breaking into specialized layers for different functions of a chain, all sorts of settlement layers, or layer one settlement layers, where Ethereum was the start, but now projects are settling onto other layer ones like Bitcoin, Solana, Tonchain, and more. There are now layer twos, little settlement layers, and layer threes roll up to those, and then the layer twos roll up to the layer one, all to continually increase throughput as well as enable people to have their own environment where they can build and customize. There's all sorts of roll-up stacks to choose from. There's optimistic chains, there's zero-knowledge proof chains, which is like math versus trusting an economic disincentive. Optimistic meaning you think people or you expect people to post the right thing and there's an economic disincentive. ZK is literally cryptographic math that is verifiable. Then there's all sorts of SDKs, software developer kits coming out, and roll-up frameworks like on Cosmos SDK with Initia, Saga, Dimension, and then there's Movement Labs, who uses Move language, which is actually invented by Facebook, and then open sourced, which is actually a really safe language and very performant. And then there are these hyper efficient data availability layers, like the one that we've built at Avail, which is one of the multiple things we're doing. And people are even separating out and using faster execution environments from totally different chains than what they're actually using on the stack side. So like the Solana virtual machine, or virtual machine is what we call VM, or the Move virtual machine, and so on. There's just so much going on out there. It's really cool to see the experimentation firsthand, but it is a lot of trial and error right now, so it's still very early. But this is how Web3 will get to internet level functionality, which right now, I don't think we're there. All right, the component specialization enables some pretty massive benefits beyond building in a monolithic blockchain environment. It enables high customizability of choosing different components like pluggable execution environments and decentralized sequencers. Sequencers is making sure to sequence the transactions. People can implement custom gas tokens. Gas means you pay a little bit to interact on that blockchain. And you could pay in the native token of the project. You could pay in stable coins, which are like dollar coins, or something else. Just adding utility, whichever token you prefer. Builders can pretty much write their own rules for their chain, as opposed to a decentralized application or dApp building on Ethereum or another chain. If they create a totally separate app chain, they can adjust all sorts of things that they couldn't otherwise. Throughput, execution speed, and so on. Where if you try to do that on a monolithic chain, you'd literally have to fork the code and create an entirely new environment. It does provide a world of experimentation to build something that works specifically for whichever project you're building, especially where function-specific app chains become even more popular going forward. But with benefits always come trade-offs, and the downside to modularity, there are multiple. One is the biggest, that, for instance, moving off of Ethereum as a dApp and to build your own app chain, the amount of decentralization you're giving away, and therefore potential uptime and censorship resistance is absolutely non-trivial. Another trade-off is economic security, as high security layer ones like Ethereum, Solana, and others have a massive, and by economic security I mean economic disincentive for malicious behavior. And an app chain or anything like that, roll-up would need to bootstrap their own economic security. Another huge issue for both a developer as well as from an end user like myself standpoint is the fragmentation of both users and liquidity/assets across all these different chains. This is a huge one, especially for me as a big DeFi or decentralized finance user. Right now, if I'm on one roll-up, I want to get to another roll-up to interact or buy something, I have to bridge to Ethereum, and then I have to bridge to this roll-up, I have to buy the asset, and if I want to get back, I have to do the same thing backwards. Again, not what the future of the internet feels like, so we're still pretty early. The last one I'll mention is in a world of 1,000 roll-ups, there's, across so many different interactive and replaceable structures, there's not much standardization. And we're seeing some standards come out, but it's still super, super early. But I think this could be a good thing as well, because it leads to more innovation, more experimentation, more failure, more lessons to come, more best practices to share. And I know we're going to see some standards come out over the modular mad science experiments we're doing. So with all this, where does Avail, where I work, fit into the picture? Again, this is more on the nerdy infrastructure side, so I apologize for the domain folks. Happy to try to connect the dots after. Like, what are we trying to solve? Why did we choose these problems? So let's go in. Avail has 3 core functionalities that we're working on and we're also working on quite a bit more that we just haven't made public yet. The first is the most performant data availability layer in the market. And if you recall, DA is one of the main core functions, essential components of a blockchain. The second is Avail Nexus we'll go into. The last is Avail Fusion. Starting with Avail DA, it makes it dirt cheap to post to a settlement layer. Could be a layer 1 like Ethereum, Bitcoin, could be layer 2, could be something totally different. And people are using many different iterations. It has the fastest time to data availability guarantees. It has the fastest DA soft or pre-confirmations. It is by far the most performant alt DA layer in the market. As opposed to being limited by the block space on a layer 1, such as with a limited and inefficient block space for Ethereum, Avail DA can and will scale indefinitely. So we can double the throughput like we just did in the past week. We're going to double it again in a couple weeks, and we're going to get to 1 gigabyte blocks. We're going to get to 10 gigabyte blocks. We already have a roadmap for that. And that's important because the congestion will never take place, and therefore fees will continually go down and or stay the same, which is really important because we want to pass those fees on to people using the chain, or we want to make them disappear entirely because when you use the internet, you're not really paying anything except for your internet subscription, and we want to get to that level of experience. It has by far the most powerful verifiability layer with a peer-to-peer light client network it's taken us years to build, but it's a really important part of what we did. This enables something that people often don't think about, which is the scalability of needing validators, these people that run full nodes for all these blockchains. And this is already becoming almost completely unsustainable due to the amount of data these chains hold and the costs of running full nodes, let alone the need for DevOps experience. These light clients do the work of full nodes, guaranteeing what's in each block is correct and verifiable. And this is, again, massively underestimated value add, since some blockchains are already at multiple terabytes of data when running a full node, and it's very expensive to maintain full nodes to verify a blockchain's information. Avail light nodes are a step in the right direction of minimizing the requirements, and it's something I can run on my smartphone, I can run on my smartwatch, Raspberry Pi. I just run a bunch on my local laptop. Then there's Avail Nexus, which I'm probably most excited about. This uses a zero-knowledge proof or ZK proof aggregation mechanism that actually makes omni-chain liquidity and composability possible without the need for traditional mint and burn bridging. So just to give a sneak peek on what that means in practical terms. Imagine a world where developers can deploy an application on only one chain and then tap into users on any chain. No more deploying on every single chain, which applications have to do right now. They have to bootstrap new users, new liquidity, and they have to pay for all the infrastructure on every one of those chains. It's unsustainable. It's what we've done to this point. This is the next step in that evolution. It is truly where developers can deploy once and truly scale everywhere. On the other side of that same coin, end users like myself can stay on one chain and interact with dApps on any chain. No more minting and burning from one chain to the next. This is great for me as I go through a lot of pain trying to interact on so many chains, and I often don't even do it anymore. This is how we get to the feel of when I'm on my phone, I click on Amazon, I buy something, you don't see that you're using a credit card app that goes to a supply chain app that goes to a shipping app. This is the internet level experience we need, where everything is from your one location. That's how we need to get to internet level operations. So it's truly a world without blockchain, or a world of blockchains without bridges, and I really think it's the future of Web3, and that's what Avail's building. And finally, there's Avail Fusion. I mentioned before that one of the biggest trade-offs of creating one's own chain is economic security. So what we've done is build a multi-token staking model. This is where battle-tested assets like Bitcoin, ETH, other tokens, and then the tokens of rollups building on Avail can be applied to increase the economic security. And then for those teams that don't want to launch a full-blown chain, but still want the flexibility of building in a modular environment, this helps solve that cold start problem. So even if they don't want to launch a token to incentivize players like validators, though they still get a lot of the benefits of an app chain would otherwise have. But if they do have a token, once integrated into Fusion, it instantly adds utility. It adds economic rewards for the people that would stake that, increasing economic security as well. And as we're nearing the end, let's kind of look at what's being built on Avail. In short, it's pretty much everything in Web3. Sovereign chains, app chains, general purpose chains, any type of roll-up really. It's actively validated services that tap into the economic security of Avail Fusion. And though all chains will be able to leverage Nexus, even layer ones, even though they don't need data availability, the dApps, even dApps will be able to leverage Nexus, again, launching on one chain, then tapping into all chains. So it will feel more like the internet, which we aren't there yet. So again, yeah, everyone building in Web3 will be enabled by the Avail ecosystem. And that's, I guess, important for this if anyone is interested in building in Web3, because you're going to have to figure out your infrastructure stack. You're going to have to figure out what the best UX, how do you get to the best UX so that people don't even know they're in the Web3 environment? Yeah. Oh, yeah. Layer over 9,000s. I like Lever better, to be honest. I'm going to capitalize Lever 9,000s. Yeah. Good call out, though. I like that. All right, so just to summarize quickly, I know I've been up here a while. Modularity is definitely an experiment, but so were blockchains 10 years ago, and now they are becoming a big part of the future. Where I worked at Goldman Sachs, when I was there, I was a big crypto nerd. There were 5 people on the digital asset team. Now they have over 100 people, and that's just a few years later, 4 years later. That's happening at JP Morgan. So finance is transitioning. It's taken a long time, but it was experimental 10 years ago. Now everyone is paying attention. Nation states are paying attention. Modularity is making things easier, less expensive, more performant, and better in practically every way, even though the UX is kind of crappy now. The UX was crappy in the 90s and 2000s with the internet, with traditional Web 2. So I think it's just a matter of time before we figure this out because of the massive benefits. So in the end, Web 3 scaling, again, just like the way Web 2 did, with function-specific microservices that specialize in a respective area of expertise for every piece of the infrastructure stack, and Avail's here for it. We're just starting to build, and we have a ton of stuff coming up that are going to really blow some socks off. All right, that's it. Here's the QR code to our website. My email's below. You can find me on any platform, Twitter, Discord, Telegram, LinkedIn. Yes, I still call it Twitter. You can search anywhere. It's Kyle A. Rojas. And thanks for listening, and happy to answer any questions.
So, Kyle, thank you. My name is Michael, and I really appreciate your explanation. Nobody's really ever explained, the whole background of blockchain and tying into the multiple layers. It made a lot more sense. Quick question, and assuming that, the ultimate goal for this is to scale like the internet is today, I've always assumed, and I think a lot of us has assumed, that some aspect of centralization is necessary to achieve mass adoption. But what you guys are doing, I think, is really cool. It's more of an interoperability between different chains. And how do you kind of differentiate that aspect of centralization versus being able to tie into multiple chains?
Yeah, I'd start by saying I don't think anything is ever going to become completely obsolete. There are still room-sized servers that are being used, even though the technology's gotten better. So I don't think we ever really get rid of something. They're just different use cases. For instance, JP Morgan built a blockchain. It's completely centralized because they have to. They're regulated. Same thing with other financial blockchains that are being built. They have to use KYC, so there's got to be a centralized component. I'm on the other spectrum in that the mission of what I'm building is decentralization, permanent blockchain information, unchangeable information, so that people have the sovereignty and freedom to do what they want. But I think every use case is going to be built. Like I know multiple traditional finance banks that are building stuff, and they're going to be building in a mostly centralized environment. I think that's important, but the benefits are still there. 24/7, mostly permissionless, access across the world where you're not limited to market hours. You don't need to deal with a bank. You don't need to deal with intermediaries, except in some cases. So I think they're all important, but I think the decentralization aspect is important because things can be shut down. They will be shut down across the world.
So can I kind of think of like Web3 as in like this big information highway, but at the same time, you know, each chain or each, I guess, actor who's within there kind of has their own sovereignty, and you can cross-communicate with one another, but you can't necessarily have somebody else coming to take down your sovereignty. Is that?
Yeah, Ethereum was built because Vitalik Buterin, or thought of because he was playing World of Warcraft. He was a super nerd, I love him. And someone took away his level 99 character. And he was like, fuck this. I put so much time into this. I need to build something that someone can't take it away. And that was a video game. When you bring governments into the mix, they will take things away. They do block people. When you take competitive businesses, you can go to the website Killed by Google. They literally make companies die. They kill companies. And imagine if you couldn't. Maybe you can acquire it and all that stuff, but you can't disrupt a blockchain if it's decentralized enough. Yeah, but you have to shut off the entire internet. Because with Bitcoin, there's hundreds of thousands of people running these nodes, and all you need is one person with that historical chain, and you could start it again. So you literally have to shut off the internet all around the world, because it's people everywhere. There's different consensus mechanisms, like Bitcoin proof of work based on electricity usage and computer models, and then Ethereum's proof of stake, where they put money down and you can lose that stake if you do something malicious. There's all these different consensus mechanisms. But it is much more permanent, it is much more immutable, and it takes, there's probably not nation states that could take down Bitcoin. And if they did, they'd be trillions of dollars in debt, and then people would just pick up the blockchain and start again, and it'd just start over, and that nation state would be broke. So it's cool. It's pretty awesome that, not only that, I like owning my own things. I like self-custody. And if I want to be comfortable, when I was working at Goldman, I worked with a lot of wealthy people, they'll always want custody. But now people in Africa, they don't need to go to their local shop, get paid, charged massive amount of fees. They can literally own the US dollar, where before it's very hard to get it. They can own the US dollar as long as they have connection to the internet. And they could transfer it anywhere in the world. So remittances are a big thing in the financial world. That's why finance is a natural fit. But then you think of everything that can be owned. You think of everything that can be disrupted, buying and selling real estate. Think how many people take money throughout that process. And what if you had non-fungible technology or non-fungible tokens that are verifiably just this person's, you can't take it away, and then you have an escrow where the entire history of that piece of real estate is on-chain verifiable. You don't have to trust an escrow company. You can literally just go look at it yourself. And then there are companies that will like unlock that and make it usable in a dashboard that you can see it. And then you can just transfer that home to another person. What about art? What about fraud in art? What about domains? An NFT, non-fungible token, which means there's only one of them. Fungible, meaning they're all kind of the same. They float together on a tax basis. Non-fungible is there's only one, provably, cryptographically, on-chain, and you can pass that to one other person, and then it's theirs permanently. It's full homomorphic encryption, and it can't be broken. Even with the new AI supercomputer stuff coming out, it's not even close to being able to be broken. And we're already working in the ecosystem to make it even stronger based on the supercomputing threats that are coming out.
I think we had a few more questions. I saw a few more hands up. Anyone else? I think we have time for maybe one more.
My old friend.
Hello, Hanson. How does Nexus work?
Nexus, all right. A ZK proof or validity proof makes it so you could mathematically verify something without seeing the contents of the information. And each ZK proof verifies everything on a chain. And then each proof, if you download the entire history of all chains into Avail DA, a validity proof, a ZK proof is created, you aggregate those. You have omni-chain, you can verify with just one proof, you aggregate that proof into one aggregated proof. You can verify the chain state, meaning wallet balances, ownership, intents, like people want to buy or sell something. You can verify everything in that one proof. And when you do that, you can just build business logic to match up the intents of everything. If somebody wants to do something, you match it up across the intents of the entire Web3 space. That means then you can not have to mint and burn across chains. It just literally updates the state of that chain. So it is truly blockchains without bridges because of that omni-chain state verification. And so that's not just the thesis, that's what we've already built on the proof aggregation side. Follow up?
Yeah, I follow that. I gotta process it for a second.
Yeah, we might need some whiskey over this conversation.
Awesome.
Whereas traditional bridging right now, you literally burn something and it mints on a new chain, and that is where the majority of the risks, that's where the hundreds of millions, billions of dollar hacks have happened. That is the biggest attack vector right now on economic insecurity, bridging. Any other questions? I'll be pouring espresso in my eyes in the back if you guys want to talk later. Thanks, everybody.